Hello everyone, welcome back to my YouTube channel. My name is Arnav Jain and I'm currently working as an SD2 at Amazon. In this video, we are going to start with one of the most important creational design patterns, the factory design pattern. Now before we move forward, we have already covered the solid principles in our previous videos. If you haven't watched those yet, I highly recommend you go back and understand them first. Because honestly, solid principles are the foundation of design patterns. If your basics are not clear, understanding design patterns properly becomes difficult. I'll attach the playlist link in the description below so you can check it out. In this design pattern series, we are starting with creational design patterns. These patterns mainly focus on object creation. They help us create objects in a flexible, scalable, and maintainable way. And today, we'll be covering one of the most important patterns from this category, the factory method pattern. Before we begin, if you find this content valuable and helpful in your learning journey, make sure to like the video and subscribe to the channel. I regularly share content around system design, design patterns, and software engineering concepts that are practical and industry focused. Turn on the bell icon so you don't miss upcoming videos in this design pattern series. So yeah, let's get started. Instead of jumping directly into definition and theoretical explanations, we will understand the factory design pattern using a very simple real-world example. Imagine you are building a logistics management application. This application is responsible for transporting goods from one place to another. Now, this is version 1 of your system, and currently your company only supports transportation via land, which means delivery through trucks. So, how will we design this? Very straightforward. Create a class called truck. Inside that class, we create a method called deliver. Whenever this method is called, it simply prints something like truck delivery completed successfully. Nothing complex. Next, we create our main business logic class called logistics app. Inside this class, we create a method called land delivery. And inside this method, we create an object of truck and called truck.deliver. Then in our main class, which acts as the client, we create an object of logistics app and call land delivery. The program runs successfully. Everything works fine. If we take a look at the UML diagram for this use case, you can clearly see the structure. We have a main class, which is our client. This main class is dependent on logistics app because it is creating an object of logistics app and calling its method. So in UML, you will see a dotted line with an arrow from main to logistics app. Now inside logistics app, we have a method called land delivery. And this logistics app class is directly creating an object of truck. That means logistics app is dependent on truck. So again, in the UML diagram, you will see a dotted line with an arrow from logistics app to truck. And inside the truck class, we have the deliver method, which contains the actual delivery related logic. That's the core functionality. Now, one very important thing to understand here. The dotted line with an arrow is not a triangle. It is a simple arrow and it represents dependency. It means class A is using or depending on class B. So here, main depends on logistics app. Logistics app depends on truck. That's it. Simple structure, nothing complex. But this small dependency chain is what later creates tight coupling and solid violations when the system grows. Now let's move to version 2. Your application becomes popular. Clients now request delivery via C as well. They want shipping support. So what will most developers naturally do? They will create another class called ship. Inside ship, they create the same deliver method and print ship delivery completed successfully. Then they go back to logistics app and add another method called C delivery. Inside that method, they create a ship object and call deliver. Now the main class can call both land delivery and sea delivery. The application works for both land and sea transport. So now, if I look at the UML diagram, the only difference between the previous diagram and this one is very simple. Earlier, our logistics app was dependent only on truck. There was just one dotted arrow going from logistics app to truck. But now, in this updated version, logistics app is using ship along with truck. So what changes in the UML? Now you will see two dotted arrows coming out of logistics app. One arrow pointing towards truck, another arrow pointing towards ship. Everything else remains the same. Let's go through the code once again. So what we have done till now is very simple. The main method, which is our client, is able to deliver via land or via sea. If the client calls land delivery, that function gets executed. Inside that function, we create a truck object and call truck.deliver. So the items are delivered via truck. Similarly, if the client calls sea delivery, we create a ship object and call ship.deliver, and the delivery happens via ship. Very simple flow. And remember, this is a very simplified example. We are not worrying about what kind of items we are delivering, what the weight is, what the distance is, how much cost is involved, and so on. In the real world, logistics systems are much more complex. You would calculate price based on weight, size, distance, maybe even fuel cost. You might decide dynamically whether to use a truck, ship, train, or even a small cart depending on the scenario. But here we are intentionally keeping it simple just to understand the factory design pattern clearly. Now that we understand the code, let me ask you, what is the problem with this code? Take a minute, pause this video, look at the code once again, and try to figure out what is wrong architecturally. And if you have not gone through the solid principles yet, I strongly recommend watching those videos first. Because without understanding solid, design patterns will just feel like memorization. Design patterns are basically solutions to violations of solid principles. Alright, so let's move forward with the problems. Problem number one, open-closed principle violation. Every time a new type of delivery is introduced, I have to modify logistics app again and again. Today it's land, tomorrow it's sea. In the future, air delivery comes. Then again, I have to go and add an air delivery method inside logistics app. So my core business logic is not closed for modification. It keeps changing whenever a new transport type is introduced. That is a direct violation of the open-closed principle. Problem number two, dependency inversion principle violation. Logistics app is directly dependent on concrete classes like truck and ship. According to the dependency inversion principle, high-level modules should not depend on low-level modules. Both should depend on abstractions. Here, logistics app is our high-level module. It contains the main business logic. Truck and ship are low-level implementation details, but our high-level module is directly depending on them. That's not correct. Ideally, logistics app should depend on an interface like vehicle, not directly on truck or ship. And remember, logistics app is our core business logic. If something goes wrong here, the entire application can break. The more concrete dependencies we add inside it, the more fragile the system becomes. So now the big question is, what's the solution? You might be thinking right now, we have already learned about the dependency inversion principle. So why not just apply that here? We can create an interface called vehicle. Inside that interface, we declare a method called deliver. Then truck implements vehicle, ship implements vehicle. Now in our logistics app, instead of creating separate methods for land and sea, we just write one method, delivery, that takes vehicle as input. And inside that method, we simply call vehicle.deliver. Now what happened? Our logistics app is no longer dependent on truck or ship. It depends only on the vehicle interface. So the dependency inversion principle is satisfied. Also, if a new vehicle like airplane comes in the future, we don't modify logistics app. We just pass a different implementation. So the open close principle also looks satisfied. Everything seems clean. But now look at the main class carefully. In the main class, we are creating a logistics app object and a truck object. Then we pass the truck object to logistics app.delivery since truck implements vehicle. So what changed? Earlier, logistics app was tightly coupled with truck. Now the client, the main class, is tightly coupled with truck. The client should not know about our low-level classes. The client should not create objects like truck or ship. The client's responsibility is very simple. It should just say, "Hey logistics app, I want delivery via land," or "Hey logistics app, I want delivery via sea." That's it. Truck and ship are our internal implementation details. With this design, we are exposing our internal design to the outside world. If tomorrow we replace truck with something else, like heavy truck or electric truck, the client code will also have to change. And that is a problem again. So what is the solution to this? The solution is the factory method design pattern. Factory design pattern is of two types. One is simple factory and another one is GOF factory method. First, we'll be starting with the simple factory method. In our current implementation, the main class is directly creating objects of low-level classes like truck and ship. This creates tight coupling. Our main class is aware of implementation details, and that is not a good design. Ideally, the main class should only say, I want delivery via land or I want delivery via sea. That's it. The main class should not know about truck. It should not know about ship. It should not create their objects. Now, the delivery method should take a parameter indicating the transportation type. It can take an enum or a string. For simplicity, let's take a string. So we pass either land or sea. Now, inside the delivery method of logistics app, there needs to be logic that decides which vehicle to choose based on the transportation type. If the type is land, it should use truck. If the type is sea, it should use ship. This decision-making logic, the logic that identifies and creates the correct object based on input, is nothing but a factory method. So what we do is create a separate class called vehicle factory. This vehicle factory contains a method named getVehicle, which takes transportation type as input. Inside this method, we write simple conditional logic. If transportation type is land, we return a new truck. If transportation type is sea, we return a new ship. If the transportation type is invalid, we throw an exception saying invalid transportation type. Simple. Now, in the delivery method of logistics app, we create an object of vehicle factory. Then we call vehicle factory.getVehicle and pass the transportation type. This method returns a vehicle object. Now, this vehicle object is either a truck or a ship, depending on what the client has requested. After receiving the vehicle, we simply call vehicle.delivery, and the delivery happens. Now, let's understand what we achieved. The main class is no longer tightly coupled to truck or ship. It only provides the transportation type. Logistics app does not directly create concrete objects. It delegates object creation to vehicle factory. Vehicle factory has a single responsibility: to provide the correct vehicle based on transportation type. Truck and ship focus only on their own behavior. Responsibilities are clearly separated. Now, is this design perfect? Not exactly. Vehicle factory violates the open close principle, because if we introduce a new vehicle like airplane, we need to modify this class. It also violates the dependency inversion principle, because it directly depends on concrete classes like truck and ship. But here's something very important. Solid principles are guidelines. They are not strict rules that must always be followed blindly. Most companies like Amazon and Google are still using the simple factory pattern in many places, and that is completely fine. Why? Because responsibilities are clearly divided. The factory creates objects. The business class handles business logic. Concrete classes handle their own behavior. If the system is not changing frequently, simple factory keeps the design clean and avoids unnecessary complexity. Good engineering is not about over-engineering. It is about choosing the right level of abstraction for your problem, and that is the essence of the simple factory pattern. Now, if we are sure that our logic is going to change rapidly again and again, and the objects that we are creating via the factory are not limited, then it's better that we move forward with the GOF factory method. In GOF factory method approach, the factory method does not have those violations of solid principles. But the main thing is that you need to understand where code simplicity matters more than strict adherence to solid principles. That is something you need to decide when you are designing the code. If you don't want any violations of solid principles, then we should use GOF. We'll be covering that in the next video. For now, let's move forward with understanding the UML diagram of simple factory method. So if you see the UML diagram, we have a main class that depends on logistics app. Logistics app is having a delivery method that takes the type of transportation as an input, which again depends on vehicle factory. Now this vehicle factory takes the type and creates an object based on that type, whether it's truck or ship. And truck is nothing but an implementation of the vehicle interface. Ship is also an implementation of the vehicle interface. So yeah, with this we have covered our simple factory method. In the next video, we'll be understanding GOF in more detail, because that is something slightly more complex and might take some time. If you like this video and it helps you in your learning journey, don't forget to like and subscribe to the channel. See you in the next video.